Using Excel to carry out pipe flow calculations is often error-prone, and occasionally you just might not realize it. We received a query from a FluidFlow trial user regarding the application of pump affinity laws for a seawater cooling system. The company had a set of template Excel files, and one of which was used to evaluate the effect on pump performance with changes in pump speed. We were evaluating a system which had a set of centrifugal pumps. The pump capacity curve data was based on an operating speed of 1200 RPM, and they needed to consider the speed of the pump at 600 RPM. They therefore used their Excel template file as seen here to determine the adjusted performance curve for the pump based on this revised speed. The designer quickly noticed a difference between the capacity curve generated by FluidFlow versus that they had created in their Excel file. We can see in their Excel file that at a speed of 600 RPM, the head coordinate starts at 29 feet at 0 gallons per minute and reduces to 13 feet at 9,000 gallons per minute. However, in FluidFlow the results were quite different. We can see in the FluidFlow chart at a speed of 600 RPM that the capacity curve starts at approximately 29 feet of head at 0 gallons per minute and reduces down to 0 feet of head just below 6,500 gallons per minute. So the question is, why do we have such a discrepancy? On further review of the template Excel file, we identified that in determining the revised pump capacity curve, the affinity laws had only been applied to the head value and not the corresponding flow value. This resulted in the generation of an erroneous curve in Excel, which gave misleading and incorrect pump performance data. When they had considered this adjusted performance data in the cooling system, they were unaware that they had obtained incorrect plant performance results. Luckily, this was identified prior to the completion of the final system design. Needless to say, this created a significant element of doubt for the user with regard to the level of accuracy of their template Excel files which they used to perform pipe flow calculations. FluidFlow has already eliminated one notable error in their design processes during the trial period. This reinforced their full trust in the package. Up until this point, the company had been using Excel templates which solved piping elements separately. The ability to consider all pipes and elements connected together in FluidFlow provided significant benefits to the design team, coupled with a high level of accuracy and reliability of results, prompted the company to select FluidFlow as their pipe flow software of choice, which was subsequently rolled out across their global sites. They had reported significant savings in plant design time and a much higher level of accuracy. Are you using Excel templates? Have they been set up correctly? Are you confident the results are accurate? Do you need to consider the operating performance of a connected piping system as opposed to individual elements solved in Excel? Do you need a tool which is easy to use and will generate the results you need fast and efficiently? Perhaps it's time you considered using FluidFlow.